Hello. So, welcome back to the second section of memory. As we discussed in the last class, we saw what is memory, what is the need for it, and what type of cognitive process this is. We also discussed about model of memory, what the model talks about, or how memory is multi-store in a single store kind of a concept. So, in the single store, memory was discussed as processes which work or which use a single store for storing, but different processes define different kinds of memories, whereas in the multiple store model there are different stores and different processes related to each store, and that is how the model is defined. We also looked at the first unit or the first part of the model that we discussed in the last class, and that was called the sensory memory. So, we looked at what is sensory memory, what is the different aspects of sensory memory, different requirements of it, and how does it work. We looked at two basic type of sensory memories. These are the visual memory and the auditory sensory memory. Now, in today's class, what we are trying to finish is short term memory. So, what is short term memory? Now, looking back at the definition of the model, memory is a three-part system, and it is also proposed by Attention-Schriffen's model of memory. The first part of which is sensory memory, and when an information is processed from sensory memory using attentional filters or intentional filters, information from sensory memory is passed on to something called the short term memory. Now, the short term memory store is basically thought of as a store which has limited capacity, but it can store information for longer duration of time, longer than the duration which is available, the durability of time which is available for the short term store or the STS. Also, the main difference between the short term memory and the sensory register, the sensory store, is the amount of information which can be stored. So, basically a large amount of information is what the sensory register holds, whereas the short term store can hold only limited information. So, let us continue our this lecture on short term store and look at some of the properties of the short term memory. So, starting with definition of what it really means, short term memory, when people mostly talk about, is a type of memory which people use for temporary holding information. Think of a scenario like this: you are on a call talking to someone, and within the call itself number is given to you by the caller. The person who is speaking to you gives you a number to dial to. Now, imagine a situation where you have nothing at your hand to write this number down. So, what do you do? How do you remember this number, or how do you make sure that the telephone number which has been passed on to you from the caller stays with you till the call ends? The most likely scenario or the most likely thing that most people do is vocally rehearse this number, and so this number, till the point of time that you are vocally rehearsing, it stays with you. If you stop rehearsal, then this number goes away, and this particular temporary store where this telephone number or the number given to you by the caller stays is what is called the short term store. So, here mostly, if not rehearsed, most information which is passed on from the sensory register stays for no longer than a second, 1 or 2 seconds. So, that is the time frame which is there, and as we saw, the time frame for which the information stores onto or stays onto the sensory register is about 100 to 150 millisecond. So, basically then short term store is a temporary store which holds on to information, little information, but for a longer duration of time. Now, as far as the definition goes, short term or primary and active stores, it is the capacity of holding small informations for some limited period of time. Now, the question again comes to us is, what is the capacity of this store? As we saw, the capacity of the other store which was the short term store was huge. It has a huge capacity, it can take in a lot of information, but then what is the capacity of the short term store? Also we talked about processes which are active during or which are inbuilt to these stores. So, one of the processes which helps in passing information from the short term store to the short term memory is called the attentional processes. So, basically attention is that process which takes in information from the short term store, and depending on people's motivation and intentions and the requirement of the task, information moves on from short term store to the short term memory. So, as concerning the capacity of the short term store, a paper was written by George Miller in 1956, and where he defines the store to be having a capacity of 7 plus or minus 2 chunks of item. Now, when I say 7 plus or minus 2 chunks of item, what I am specifically trying to tell you here is that chunk is a word, and it's a conceptual word. So, 7 plus or minus 2 chunks does not mean that you have to have 9 or 5 items into it, but a chunks of an item. So, basically let us go ahead and define what a chunk is. So, chunk is a process, or chunking is a process where meaningful units or meaningful materials which are similar to each other are clubbed together, are categorized together. We will look into this in the chapter of categorization, how does this process happen, but for now chunking is a process of basically putting into a similar bin items which are conceptually or meaningfully similar in nature. For example, letters can form a chunk, digits can form a chunk, and certain other for example visual stimuli can form a chunk, and that kind of a thing is chunking. So, the capacity which has been defined by George Miller in his paper is called 7 plus or minus 2. That is the maximum capacity of information which can be stored into the short term memory. Now, the thing is, this is also called the magical number, and very recent studies by NICER demonstrates that it is not 7 plus or minus 2 items, but it is rather 4 plus or minus 2 items that is the capacity of the short term store. So, one thing is the capacity. The next thing, so example of how chunking really works. So, if I show you this string which is at the top of this particular slide, and if I ask you to remember this, if I show this string to you for let us say 100 millisecond or for 1 second, and then I ask you back to relate back what are the number of things that you are seeing, or what are the number of letters that you are seeing here, it becomes a difficult job. So, I will demonstrate what chunking is. What chunking really does is to make meaningful sentences or club meaningful sentences together. So, one way to remember this whole string is to understand the fact that this string has acronyms from the famous detective agencies or basically security agencies of the world. So, what I do is, if I can break into 3 chunks, so FBI is one agency, NSA is another agency, KGB is an agency, CBI is an agency, CIA is an agency, MI5 is an agency, and BND is an agency. So, these basically can be chunked into smaller chunks. The meaning of the chunk or the meaning of the bin which holds these chunks together is security agencies, and that way you will be able to remember this whole number of digits or this whole string of digits. So, this is basically what is the process of chunking. Then another thing that we want to know is how are things coded into STM. Now, it was very explicit to us that coding in the short term store was dependent on modality. So, different modalities had different codes in the short term store. So, is it also true for our STM? What is the way in which information is coded into the STM? That is an interesting thing to be looked at. Now, the coding in STM generally happens to be in terms of the acoustic feature or in terms of the acoustic way. So, information mostly are held on to your STM in an acoustic trace, which basically means that this subvocal rehearsal that we are talking about in our earlier example, where we were looking at how this number was given to you by your friend over a telephone, and so you needed to dial this number. What you tend to do is mentally rehearse it, and so when you are mentally rehearsing it, you are doing a acoustic rehearsal. Now, just to prove the fact that it is acoustic trace, that is the way of how items are coded or how items are stored onto the short term store or short term memory. Conrad 1964, he conducted a famous experiment, and so what his experiment was, he gave people some letters to remember, a string of letters to remember, and later on asked them to remember these letters back. For example, K, GC or TBC kind of a thing. And what he found out from the remembrance, that when people tried to remember these letters back, what he found out that people confused or committed errors by retrieving in retrieval by those letters which sounded similar together. So, basically letters which sounded similar or which appeared similar, they created more confusions or more errors than for those letter strings in which letters were not similar together. For example, in terms of when a visual presentation of letters were done, so two presentation of these letters were done. In one case, KGC kind of a thing was given to people, and in an auditory manner or through an auditory stimulus. In the other version of the experiment, this KGC was shown to people, and so when this kind of a stimulus was shown to people, it was that people made more confusions when auditory testing was done. And what happened here is that K or the G confused more with C. People made more confusions with C, whereas in terms of the visual, people didn't confuse with the letters G and C. So, it is basically the acoustic code, or it is basically the acoustics or the phonemes, the basic speech sound which made the confusion, and that led to the idea that it is coding which happens in the STM is mostly in the acoustic form. Neath in 1988, he found that people use acoustic code dominantly for STM storage and recall. So, basically people do some kind of a subvocal rehearsal, and it is not mental images, it is not imagery that people make of items in the STM. People generally make an acoustic trace or an acoustic image, I would say. So, let us not use the word image here. So, an acoustic trace of any information which has to be put into the STM, and basically then remember it that way. Now, the question then which is in front of us right now is, what is the retention duration and how does forgetting take place in STM. Now, to prove the way in which retention is done in STM, or how items are retained in STM, and what is the way in which forgetting takes place in STM, several experiments were discussed. And so, what I will try and do at present is show you two different versions of the experiment. In first version, which is called the Brown and Peterson task, we will see that decay has been named as the reason for forgetting, whereas in the Vog and Norman task, I will try and show you that the same explanations, the same results from the from the Peterson and Brown experiment are how it is explained in terms of interference. So, basically there are several theories of how items get moved out or items are forgotten, and so there are two popular theories of it. One is the decay theory, which basically goes ahead and says that items which are not used for a longer period of time, they decay. So, what happens is that the memory trace is erased, and they get decayed or without use. The theory of not use says that they slowly wither away with time. So, the trace itself disappears. Another theory of forgetting is the interference theory, which says that if items of similar nature, they come in contact with each other, or if one item is presented and a second item which is similar in nature to the first item is presented alongside, then both the items will compete with each other and there will be an interference. So, basically in the next section in long term memory, when we will discuss, we will also discuss on to the interference phenomena. For now, these are the two modes of forgetting. So, what people were wondering is what is the nature of forgetting, or how things are forgotten into STM and how they are stored. So, let us then look at these experiments one by one. The first experiment is called the Brown and Peterson task. So, what is the task all about? And so, this experiment was done by Brown and Peterson in 1959. So, what is the experiment all about? Now, in the Brown and Peterson experiment, it is a very easy experiment to look at. A digit string was presented to people. So, a digit string like this was presented to people, and what they had to do, these digit strings were generally a trigram, a 3-letter word or 3-letter trigram. A trigram is basically a 3-letter word which does not make a sense, because if you have senseful word here, then the chances of you recalling it will be better because it makes meaning, and so a trigram is used. And basically the starting point of trigram or who started the use of trigram was basically Ibn Gauss. What he did was he created 3-letter words of the format CVC, which is the consonant vowel consonant format, and so in CVC he combined 3 words together or 3 letters of the English language together, so that they do not make any meaning. For example, KHC or QKT. Now, these words do not make meaning, and so they are combined together, and this is what a trigram is. So, in this particular experiment, an arrangement was done in which people were shown this kind of trigram, and so after they were shown this trigram, they were asked to commit this trigram to memory. So, basically someone is shown this trigram and they are asked to commit this to memory. Later on, they were said to count back from 1000 in threes. So, the first will be 9, 9, let us say 7, and then the next will be 997 minus 3. So, will be 9, 9, 4, and so on and so forth. So, keep on counting like this. So, a task was introduced. So, the working of the task is that this kind of a trigram was introduced. People were made to commit this to memory, to subvocally remember it. So, we are given this task and subvocally remember it, and later on a delay distractor task like this was given. It is called the n back counting task. Here what you need to do is that you have to count back in digits of 3, this kind of a thing, and keep on counting. Now, people were stopped at several points of time starting from 20 seconds delay. So, within the first 20 seconds they were so people remembered this task and they started counting back, and after the first 20 seconds they were stopped and asked to relate back this trigram. So, this is called the recall trigram phrase, in which after the first 20 seconds people were asked to stop. So, within this 20 seconds people are counting back. Now, one thing is that this counting back task, the n back count back counting task as it is called, it requires a huge amount of short term memory, it requires a huge amount of attention, and so most attentional resources will be diverted to it, and so chances of any chance of people to basically subvocal rehearse this particular thing is not possible. It is not at all possible in this task, and so this was to demonstrate the fact that this KHR or this recall was basically due to decay. Now, people were stopped at 2 seconds time after the counting started. So, they were made to recall the trigram after 2 seconds, 4 seconds, 6 seconds till 20 seconds. So, after every 2 seconds they were made to stop this counting task and recall back the trigram. What really happened? What is the result of this experiment? The result of this experiment showed that after 18 seconds, so this is what the result looks like. If you look into it, initially what happened is, this is the relative accuracy which is there in the recall interval of time. So, what the first thing that shows or that is evident from this particular result is that at 18 second the curve becomes a sort of asymptotic, and so which basically means that the recall accuracy doesn't fall anymore. So, the curve runs parallel to this, but if you look into it, for the first 3 seconds there is a maximum fall of accuracy. So, this is the portion, if I draw this, then this is the kind of portion which is there. Immediately there is an accuracy. So, just let us say half a second, the accuracy is almost 1, which means that people are almost highly accurate, 80% accurate in recalling the, or more than 85% accurate in recalling the trigram back. But then as you proceed in time, by the first third second of still the start of that counting task, people almost lose the accuracy by, or the accuracy drops down by 42 to 43%. By the next 6 seconds, it drops to almost, let us say, around 35%, and then similarly it keeps on dropping till it becomes stable at 18 seconds. And this idea gave, or this task gave two prominent results. One, that decay is the reason for the forgetting. Since the task was so heavy, the working memory task which was used was so heavy, what happened is people did not get time to repeat, and so the trace of memory trace of this task went on decreasing till it reached a very low level, which is nearly 0.1 here, the 0.1 chances of accuracy here after 18 seconds. Also, another important thing that was demonstrated here was that the time period for which any item gets stored onto the short term store, and the time period which was determined through their experiments by Brown and Peterson was 18 to 20 second. This is the time period through which an item will be in your short term memory if not rehearsed, and after 20 seconds if rehearsal does not happen, then most items from the short term memory will go away, and so the duration of the short term memory from this experiment is 20 seconds. Now, Brown and Peterson task, which explains decay as the reason for the delay, can also be explained by the Vaughan Norman task, but before that let us look at the results. From Brown and Peterson task, the study interpreted that failure to recall occurs during the decay of, due to decay of memory traces, and so within the first 20 seconds. Now, another group, as I said, that Vaughan Norman tried to explain this result in terms of interference, and so what they said is that they challenged the decay theory of forgetting in memory and proposed a different mechanism which is called interference. So, interference, as I explained to you, is a phenomena in which what happens is that two items which are similar in nature, they compete with each other, and so they block the recall of one item. The important thing to remember is that they have to be, two tasks have to be similar in nature and they have to be competing. If they are not competing, if people are not focusing on both the tasks, then the interference phenomena will not happen. So, basically then interference theory says that some information displaces another information, making the former hard to retrieve. As the second item competes with the first item, and since they are similar in nature, people confuse and the second item is pushed out or interfered out from remembering. So, an explanation of the same Brown and Peterson task, or Vaughan Norman's interpretation of what happens in terms of forgetting and time delay in STM, another task was designed which is called the probe digit task for explaining the interference phenomena or interference forgetting from short term memory. Now, what was the task? It is a very easy task to look at. So, it is a 16 digit number task. So, a 16 digit is presented to you at one go. So, you have things like 2, 4, 6, 8, 4, 6, 3, 4, 3, 6, 8, 9, 4, 3, 4, 2, 3, 4, 5, 6. So, this kind of a setup is presented to you. So, one example is given here. The last digit, now this digit then serves as a cue. So, a digit like this, a string like this is presented to people, and what they have to do is to first recognize the last digit, and this serves as a cue. Now, what is the task? The task is to basically go ahead and name the letter which preceded the first occurrence of the last word here. What do I mean by this? What I mean by this is that this 6, which is the last digit in this string, this serves as a cue, and so what is the first occurrence of this? The first occurrence of this is here, and so the letter which precedes the first occurrence of the 6 is 4, and so what people had to say is 4 was the correct answer. So, you had to, people have to, last digit in the number is a cue for the participant to report the number that first came after the first occurrence of the cue in the number, and so that is what it is, and so 4 is the answer here. So, this is the task. A 16 digit number is presented, you have to remember the last digit, remember the first occurrence of the last digit, and remember the number which preceded the first occurrence of the last digit. Now, there are two versions of this task. In the first version, letters were presented very fast. So, either very quickly at the rate of 4 digit per second. So, this whole string was presented at the rate of 4 digit per second, and so people had to then go ahead, and so first the string was presented, and then the string was presented in a manner in that 4 digits very quickly were presented to people, and then from the last one. So, 4 for the 16s, 4 presentation are there, 4 digits presented together into 4 different times makes it 16. So, you have to remember the last one, remember the last digit, and then remember where the first occurrence or the last digit on the 4th panel was there, and then go ahead and tell me the first number which occurred into the first occurrence of the last cue. Or there was another presentation which was 1 digit per second. So, 16 seconds, 16 repetitions were done here, 4 repetitions were done with 4 digits, or a 16 repetition, one number at a time was presented. People were asked to do the task. Now, Vaughan and Norman, they reasoned that if decay caused forgetting in STM, then participant receiving a slow rate of presentation should not be as good at recalling digits from early in the number, which basically means that if the first occurrence of the last digit in the 16 digit string comes in the first half or towards the middle of the list, then people should not be able to remember this. But this is not what happened. Capel and Underwood, they found that forgetting in the Brown and Peterson task does not happen until after few trials. So, what happens is this is not the answer that they found that there were similar kind of forgetting which was there, but then if words were similar, if decay is the reason, then this kind of answer should come, but this is not what they found. They found that quite similar kind of forgetting into both the versions of the task. And so, this Capel and Underwood, they found that forgetting in the Brown and Peterson task does not happen until a few trials have happened. They suggested that over time proactive interference builds up. So, what happens is that in the 4 into 4 kind of a set, what happens is due to proactive interference, if digits appear in the later half, if the first presentation of the cue happened in the later half, forgetting was more, but if the presentation was in the earlier half, forgetting was less. And so, this kind of an result was what was formed from the Vaughan and Norman, which basically suggests that interference is the reason for forgetting. So, this is how the task looked like. This is a 16 digit task, this is the first occurrence of it, and this is what you tend to remember, and this is what effects of presentation rate versus number of interfering item is looked at. So, if 4 items are there, then you tend to have, so if you look here, the number of interfering items are 5. If this is there at 4 second, both the 1 second and the 4 second presentations are almost similar in terms of relative accuracy, but then if the number of digits, interfering digits, number of interfering items are more, which means that the number of letters which are presented or number of letters which precede the first occurrence of the cue. So, if my cue is like this, let us say 16 digit, and so 4 digits, so a block of 4 into 4, what happens is if my cue, the first occurrence of cue falls here somewhere, then the chances of forgetting, the accuracy of will go down in the 4 presentation group, but not in the 1 presentation group. But then what happens is if I am presenting it in one word at a time, there won't be any interference, and so there will be no forgetting at all here. And so, this basically is a concrete example to basically go ahead and say that interference is the reason for forgetting. And so, this graph in itself explains that if 4 words per second is there and how it relates to number of interfering items. If the number of interfering item is 5, this is where both the list matches, but as it goes to 7, the one word has lower accuracy than the 4 word items. And this happens because in the one word the interference will be more, since one words are presented one after another, and so there will be a lot of interference, but in this there are only 4 presentations, and the interference will be less. Then the question is forgetting from STM a decay or interference related phenomena? Now, it is a badly posed question. Why? Because it rules out the possibility for loss by both the phenomena. And so, badly said in 1990, he argues that trace decay does occur from STM. Altman and Gray also proposed that decay does occur in fact and essential to avoid catastrophic proactive interferences, which basically both these people go ahead and say that it is not one over the other kind of a thing. Both the factors, decay and interference, they go ahead and then they basically relate to each other to actually go ahead and show that this kind of interference has happened, or both the items are responsible for the interference. Now, these authors believe that information must be updated frequently in memory. Its current value decays to prevent interference with the previous value. So, another interesting thing that can be that was looked at is that if interference is the reason why forgetting happens in short term memory, phenomena which is called the release from proactive interference. Now, as we saw in the Vaughan and Norman study, it was basically proactive interference which was the reason why forgetting happened, and forgetting happened in the one word item. Very clear explanation. What happens is, since it is one word presentation, so there will be 16 occurrences of it, and so more number of interferences, but in the 4 word items or 4 word presentation, there are only 4 different presentations which are there, and so interferences are less, the proactive interferences are less in number. And so, what we have here, an interesting thing that we have here is that a phenomena called proactive release. Now, what is proactive release? So, Wickens and Bond, an experiment was done by Wickens and Bond in 1963, and what these people said is that the phenomena of proactive release from proactive interference should be evident if interference is the reason for forgetting in the Brown-Peterson task. Now, what this phenomena really says is that if interference happens because similar items are presented. So, if items are different items are presented to people, then what would happen is they would show interference or the performance would increase, and that is what exactly happened. So, what these people showed that if similar type of items was used in Brown and Peterson task, so if letters only were used, then people had higher forgetting rate, and that because it was due to interference. But then if on one particular presentation you had letters as well as digits coming in. So, you have a number, a 16 digit number where you have letters and digits filled into it, and so you have to tell me the last occurrence of either a letter and a digit. So, the display would look like something like 1 2 4 A C 6 4 3 D K kind of a thing, and let us say E is the last here, and so or A is the last here, and so you have to tell me the digit 4 which comes after the first occurrence of the letter A. In this case, the forgetting was known to be less. The reason given was release from proactive interference, which means that when items were switched. So, here what happened is items were switched, and so some items were letters and some items were numbers. In this case, the proactive interferences were less, and so in those cases where you had to remember a letter, a digit after a letter, in those cases the interferences were less. But if let us say if the last word here is not K, let us say if it is 4, and people have to remember the number which comes, or the item which comes after the first occurrence of 4, which is 2. Now, since 2 and 4 are both digits, and so they will create more proactive interference. But if let us say the last word is here A, or let us say that this is 4 and A comes in before 4, in this cases A is remembered more. So, if the word which appears after the first occurrence of the Q is a different word, it is not the same as the one which is the Q, then proactive interferences will be very less, because for the phenomena which is called the release from proactive interference. So, how is information retrieved from short term memory? That is another thing to be looked at and interesting. So, we looked at how it is stored, what is the manner in which forgetting happens, what is the time and what is the duration for which an item stays in STM, and what is the kind of coding which happens in STM. So, in this particular next step, we will look into how is information retrieved from STM, what is the way in it. So, Saul Steinberg, he designed an experiment to look at how items are actually retrieved back from STM, and what did he find. So, what was his task like? His task was search for information in serial or parallel form. So, he had people look at a display like this, where 7 or few letters were, so 7 or few letters were given to people to be kept in the memory bank, to be remembered into their memory. And then later on a Q was presented to people. So, let us say we have 7 or few letters which people have to remember. So, these letters are A, B, K, T kind of a thing, and then they are presented with C, people are presented with C, and what they have to look at is to find out whether this C is presented here or not. And so, they have to hold this in memory and then later on verify this Q or this probe Q whether it is present here or not. And so, from his experiments he came up with a very interesting example or a very interesting proposal. And what is this proposal? He conducted this kind of an experiment and found some interesting results. What was it? First, something called parallel search happened. So, when comparison of probe is done with all items stored in the STM at the same time, then it is something called parallel search. So, if C is searched with every of this item, every one of this item, it is a parallel search, but when a comparison or the probe is done with all items stored in the STM one at a time, it is called the serial search. So, the question here was this kind of two searches could be the result of the experiment. Now, if you remember the first lecture, we talked about something called structure process trade off, and we saw how Steinberg's the same experiment is described here, how Saul Steinberg went ahead and described this whole process of serial versus parallel search, and he gave reasons for what really happens, how the structure and the process compensate for each other, and it is the same thing. Now, within the serial search, Steinberg basically proposed that there are two versions of the serial search. The one is called the self terminating search, in which what happens is, as soon as, so this C will be searched with A or compared with A. If it is not a match, this C will again go into searching with B, which is the next letter. So, this is my letter items which is in the memory set, and this is my probe. So, this C goes ahead and matches, I have C here, and when as soon as the C matches with this, a self termination happens. So, the list is not further searched off, although the list has 7 items. So, as soon as this C is there, here I have a no. So, the match or the matching proceeds to B. If it is not matched here, it will proceed here, but as soon as the match is there, a self termination will happen, a self termination will take place. But in another form of the search, which is called the exhaustive search, what Steinberg says is that no matter the fact that this C is matched here, this C is again matched to the next item, which could be a B or which could be another C. So, the whole number of items which are there in the memory set will be searched one after another with the probe, and that is what is called the serial exhaustive search. And what Steinberg argued is that the way in which short term memory is searched is basically the serial exhaustive search. So, no matter even if we get a clear search, first of all there are no parallel searches in STM, there are always serial searches, and even if the serial search is done, it is not a self terminating search. Even if a match is found to the probe, even if some item matches the item that you are looking for in your STM, the search will continue till the end of the list. This is because the exhaustive search takes place, and the one probable reason could be the fact that multiple copies of the item would be there, and so the requirement of that makes you to do something called the serial exhaustive search. And so to test, so a review done by Hunt 1978 found that people of all sorts showed results consistent with the idea that retrieval from STM uses serial exhaustive search, although the search rate changes with the group. Now, DeRosa and Decay 1976 demonstrated that with certain stimuli, people apparently do search STM in a parallel way. So, basically DeRosa came up with an experiment to show that both the serial as well as the parallel search does happen in STM, and so they designed a sequence kind of a stimuli to test that, and the results of their study was, so first let us look at the stimuli that they used for their experiment. So, in their experiment they gave a situation like this, stimulus like this. Now, if you look at the stimulus, there are 1, 2, 3, 4, 5 different stimuli, and what we look at is basically a stimuli in action. So, there are several natural actions of the stimuli. For example, look at this person who is playing a golf. So, you see that it moves from frame to frame. As you look at his diver, so he gets up and prepares himself, make this move, bends down, launches himself into the air, then dives forward, makes this move, dives forward and then lands below. Or look at how this bird goes and flies. So, these are the ordinal positions, these are the positions in which basically the sequence of action should go, and these are the number of actions that these stimuli is done. So, what is the result of a study like this? What happens in a study like this? So, in a study like this, DeRosa found that the stimuli consisted both of, as I said, it consisted of number of ordered pictures in one after another, and so the result of the study says that if the memory set consisted of some randomly selected subset of 9 pictures from any of the sets, the results were similar to Sternberg's results. So, if let us say that I give you a number of positions to verify. So, what I do is, let us say from the first stimuli here, I take in ordinal positions 1, 3, 2, 6, 9, 4, 9, and then I ask you to verify whether 5 is there or let us say 4 is there in this set or not. So, that is what you need to do. So, this is the 4th position which is there, and I have selected the first position, the 3rd position, the 4th position, obviously the 2nd position, then so this is the way in which it is the 6th position followed by the 4th position and the 9th position, and so they are in an unordered list, and so you will have to go and search whether this is there or not. So, in this kind of search, when the queue has to be searched in a display like this, in a situation like this, in a feature like this, then a serial exhaustive search is what happens here. But then interestingly, if an ordered set is used, so instead of using this kind of a random sequence, if I give an ordered set, so if I take positions number 1, 3, 5, 7, 8 and 9, and if I give you to find whether 3 is present here or not, parallel search exists. So, items when they are presented randomly, if the memory set, if the test item that you have to find out in the memory set, and the memory set consists an unordered kind of a setup and unordered kind of a list where all ordinal positions or randomly mixed ordinal positions are present, then in those cases what really happens is the search is more or less of the type which is popular to what Sternberg says, it is serial exhaustive search in nature. But then if I have an ordered position, or if I have an ordered search, in those cases, so if I take 1, 3, 5, 7, 8, 9 and search whether 3 is present or not, there are parallel searches which results here. So, that is what this says. So, results were similar to Sternberg when random selected subset was taken, but when an ordered subset was taken, took participants no longer to search for 5 items, then for 2, and so generally there was parallel. So, this result suggests that SCM does treat organized material in different form the organized material. Also, memory process apparently work differently as a function of material, that has to be remembered. So, basically the search is can be both parallel and serial, or different types of searches are there, but when it is ordered material, it could be serial exhaustive. When it is not ordered, maybe it is parallel, or it could be a simple self terminating self search. So, depending on the material which is being presented and the type of task which is there, the it is decided what kind of search will happen. Now, the problem was that STM, as we saw here, is basically then quickly define what it is. It is basically a short term memory. STM is a short term store which has, first of all, a limited capacity. So, one of the things which we should be aware of is that it has a limited capacity, and the capacity here is 7 plus or minus 2, although Ian Neath came up with a new idea that it has 4 plus or minus 2 items. That is what it is, but we will not discuss this right now. We will focus on to the original Miller's idea that it has 7 plus or minus 2 items to be looked at. Then the second thing is the way items are coded, and so mostly acoustic coding happens in short term memory. The type of coding that happens in short term memory, or the way items are encoded onto short term memory, is acoustic in nature. It is basically in terms of verbal, and rehearsal is the main reason for this kind of storage. And then the time period for which any item can remain in the short term store without being repetition is 18 to 20 seconds, and this is an output from the Brown and Peterson task. Also, the fact that forgetting mostly in short term memory can happen both from decay and from interference. Mostly it is interference, but then we have decay also as a reason, and so mostly it is a interplay between decay and interference which lets you lose memories from short term store. And the last point that has to be that can be remembered here, or that has any value here, is that retrieval from this kind of a store is basically mostly in a serial exhaustive manner. So, serial exhaustive search basically, or serial exhaustive way of replacement of this particular materials, but depending on the type of material used, this serial exhaustive search could also turn out to be parallel exhaustive search or some other form of search which is or which could be needed. Now, we have looked at what STM is and what it does, and what is the various ways in which STM works. But there was a debate which was going on within the community of cognitive psychologists, and that was that at times STM was somehow not approved of. What do I mean by this? If you look at the first instance of my definition of the short term store, I explained to you there is something called the serial position effect. And so, what we found out in the serial position effect is it's an effect like this. So, what happens is a list of numbers are given to you, a list of items are given to you and asked to remember. Then what happens is items at the beginning of the list and items at the end of the list are remembered more than items at the middle of the list, and those two things are called the primacy and recency effect. Now, it was found out in several experiments that if items which had some kind of a personal meaning to people, and even if they were presented in the middle of the list, they had a higher chance of remembering. And so, this led several people or several psychologists to go ahead and question this idea of a single store which does not do anything, but stores information for some period of time and no act onto it. The question this particular store. So, the question was whether short term store was a static store or a dynamic store, and a number of questions was done. Also, this interference, does interference work on to all kind of items which is stored. So, if there is a visual item and if there is an auditory item, whether this kind of interference that we talk about, whether it happens on to different modalities or different encodings of items which is there. So, if different versions of items are presented or different types of items are presented, whether this interference will be there or not, and several studies reported that it was not there, and so was conceived the idea of working memory. So, in the upcoming class we will look into what is working memory and how does this working memory concept go ahead and take up or basically replace the concept of short term memory. Thank you.